Okay, there we go. So, welcome again. Today we have our open infrastructure session. We have three amazing speakers. I am going just to quickly tell you, we'll have Emi Tsang from Invest in Open Infrastructure. We also have Fotis from Evers and Elixir Greece. And we also have Senia Perez from Elixir UK. So they will all tell you about the different organizations, the different initiatives that they work on with a focus on open infrastructure. We will have a Q&A, a short Q&A after each talk. You can use the Framapad for the questions, notes, links that might be interesting. Also, the chat will be monitoring that. But also, you're more than welcome to just raise your hand and unmute after the talk is finished. So please, make use of the time with them. They are experts in their fields, and we are very happy to have them here. So
thanks so much, everyone. Thank you, Sarah, for the invitation here. I'm not hoping to keep you all too long on this. I did wanted to sort of start with a bit of an introduction on what open infrastructure is and why you should care, really. But yeah, hopefully we'll also get to leave a bit more time for any questions, discussions, etc. And hopefully this is going to be, an interesting and relevant presentation and discussion for you. So Sarah was introducing, my name is Emmy. I am the Director of Finance and Operations at Invest in Open Infrastructure. I'm going to spend maybe 1 to 2 minutes on what we do at Invest in Open Infrastructure, or IOI. So primarily we're working across the open research infrastructure ecosystem on really strengthening some of the financial, operational, and governance foundations that allow these infrastructures to survive and thrive, and thereby also allowing research and science to thrive. We have quite a unique view of the ecosystem because we are not a funder, not an infrastructure ourselves. We have other folks here who are actually infrastructure. So I'd also love to sort of highlight their work and bring them in. But yes, we do three main areas of work, I would say. So first of all is research. We investigate the funding trends and gaps in infrastructures, funding and support for them, mainly financially, but also in other aspects. We work directly with infrastructures as well through our strategic support. And so this is really working directly with core teams of infrastructure developers and maintainers, looking at their sustainability strategy in particular. And then last but not least, we run funding pilots. So these are experiments where we create with the community to try and see what sort of new catalytic funding strategies we can bring to the ecosystem and test it out and see what the impacts may be. I was saying that we have quite a unique view because we're not a funder and not an infrastructure, but we do work with funders and institutions, academic institutions, research institutions, as well as infrastructures as well. You see some of our partners and funders on the screen here. And so this sort of cross ecosystem position gives us quite a unique view on where the system as a whole is under strain at the moment. And I'll share some of what we're seeing and noting later on in this presentation as well. So before I dive into all of that, I thought it's good to sort of start with what open infrastructure, open science infrastructure is. And the easiest thing to do here is probably to look at how other people have defined open infrastructure, using the heavy double quotes here for the definition. But so the UNESCO recommendation on open science is actually a very beautiful description of what they consider open science infrastructure. I'm highlighting, because there's a lot of text here, I'm highlighting the main bits, which is that open science infrastructure refer to shared research infrastructure that are needed to support open science and serve the needs of different communities. The stuff between the highlighted bit is really the sort of vast number of examples of things that could be considered infrastructure that, again, is ultimately towards enabling and supporting open science and serving the needs of different scientific communities, right? So you have, if you think about, I think usually when I try to when people ask me what open infrastructure is, I sort of ask the question back and ask you to think about, as the researcher, as someone who's working on research and enabling research, what do you rely on a day-to-day basis, right? Like, and that, for you, you will realize that, maybe it is all the things from, if you are in like, let's say, life sciences research, which this is my background, so I'm most familiar with, you may be using programming languages, but also like different workflow tools, but also different like electronic lab notebooks or um, virtual machines, compute, etc. Like these are all infrastructures that you're relying on, but also like there's hardware, right? Like if you're doing microscopy, for example, then the microscope is an infrastructure. And so by giving that example, I also hope that I'm conveying the story that infrastructure is hard to define because it is so contextual. It really depends on who you are, what's your research field, what is your background, what do you need to do, and that is I hope you can appreciate that is a different story for people in different roles. Like if you are, for example, a data steward versus someone who is managing scientific communities, like the things that you rely on are maybe overlapping, but also distinct. And so it is really, really hard to give it an overall definition, but I hope you appreciate that it is a feature, not a bug, right? It is part of what infrastructure is. And you think about it I'll come back to this as well, in the sort of road and bridges analogy for infrastructure, right? Like what is important in your day-to-day life as infrastructure is also dependent on your lifestyle, where you live, what are you trying to achieve most of the time in day-to-day circumstances. And so yeah, it is complex, it is dynamic, it is social technical, it is all of those beautiful things. And yeah, this is also why it is sometimes hard to talk about support and sustainability of our infrastructure. Anyway, again, without getting ahead of myself, if you still, oftentimes when I get to this point of the conversation, people then are like, okay, but I still don't understand what infrastructures are. So at Invest in Open Infrastructure, or IOI, we've built this tool called InfraFinder. It is a tool that helps people discover the infrastructures and sort of assess them to understand whether or not they would meet their needs. So you can see it as sort of a catalog with some filters, if you will. But it is if you head there, you'll see names of actual things that are open infrastructures, and so some of them you may be familiar to you, some of them not, but it may give you sort of more concrete ideas as to what some open infrastructures are. I will upfront say that we've got 142 open infrastructures up on InfraFinder right now. This is not everything in the world. It's very hard to get everyone. It's a big effort to sort of assemble all this data, etc. But hopefully it gives you an idea of what these infrastructures technically look like and what they are, who they are. Yeah. And of course, if you are running an infrastructure and you consider yourself an open infrastructure and you are currently not in InfraFinder, I always recommend people to sort of head to InfraFinder and try and see if you would like to be listed on InfraFinder. And there are ways to do that on the website as well. I'm also happy to talk you through that in the question section. All right, so I already alluded somewhat to this. I think some of the complexity that comes with understanding infrastructure and sort of almost caring about that, right? Is that it is not one thing. It is a complex ecosystem of stuff with a lot of interdependent layers. So I was using this diagram for a talk that I gave 2 weeks ago. And it seemed to have resonated, and it was drawn with a specific narrative in mind, but I thought it also works well here. So sometimes when especially if you come from a research field or are in a position that works heavily with research data, then some of the most visible layers of research infrastructure, open infrastructure, would be like data repositories, for example, things like Zenodo or Dryad or Dataverse, right? Like these are the layers that often a lot of people would interact directly with and deposit the data to share the data, etc. But then actually sort of sitting below that, there are a whole stack of interdependent layers from things like metadata standards to software and tooling, which I'm sure Fortis would talk more about, and things like community capacity and norm and data stewards and compute and storage infrastructure, persistent identifiers, legal and ethical frameworks, and also sustainable funding models for all of this. Like these are all dependent on each other, and some of it is less sort of software or digital, is more human infrastructure, right? But they're nevertheless infrastructure, and they're nevertheless dependent on each other in the sense that you can't have a functioning data repository or software or metadata standard indeed without some of the things like community norms and culture and coordination infrastructure and data curation and stewardship expertise. So a lot of these layers are sort of more hidden. They are also, because we at IOI we spend a lot of time thinking about funding and sustainability, they're also often the layers that are chronically underfunded and relatively hard to get funding for. So it's definitely, understand as a user, the reason you should care is really that some of the things that we most rely on day to day is dependent on a lot of things that are load bearing and are oftentimes not very resilient and not very sustainable because of all the things in the ecosystem right now that I'll go on to. So as I said, like the entire infrastructure ecosystem is constantly facing a lot of challenges. And this here is by no means an exhaustive list. It is I would say a very IOI lens list because we do have a particular focus around funding and financial sustainability as well as governance. And so, but hopefully that sort of lens is useful here as well. That we have a annual sort of landscape of lay of the land report, which we call State of Open Infrastructure, that we release every year. I have put a link to the QR code here for last year's iteration of this report, where you will see a lot more of the evidence, hard evidence, if you will, in the data, quantitative or qualitative, backing up some of these challenges that I'm flagging here on a very high level. So I do encourage you to read that, and we will have an iteration coming out hopefully this September as well for 2026. So some of these challenges may resonate with you. I think I was at a panel earlier this week in a room of infrastructures sort of organizations, and within the first 2 minutes of the question and answers, basically the funding challenge had come up already. So funding and financial sustainability is a core challenge experienced by many open infrastructures in the space, I would say. There are a few reasons for that we have in our experience, in our research and our experience with working with infrastructures that we've come to understand. First of all, is that research infrastructure in particular are most of the time funded like research. So that meaning, funders like to see new stuff. They don't really want to invest in existing stuff and maintenance. And so, it creates a problem that the infrastructure, when they're new, they get first grants for 2 to 3 years, and then there's nothing coming after that. And then they have to sort of, they might have become important to certain research workflows by that point, but then there is no more financial support for whatever they're doing, whatever they're maintaining. So that is a problem. And I think it's a relatively well-known one. And we've got some very nice sort of evidence from analyzing over $500 million of grant funding to really substantiate that this is a real challenge in the space. Project-based funding as well, I've just alluded to that, is the fact that, again, the grant funding is oftentimes 2 to 3 years. So you're you write a grant proposal for a specific project, right? But then you have to spend that money on that particular piece of work. And oftentimes what you see is when it comes to running an infrastructure or a service, a lot that it's not everything is project based, right? There's just plain operational work that needs to happen that aren't exactly like a project fundable a fundable project in the traditional grant sense. There are also times that you just need to react and respond to ongoing changes, and I'll talk about that more in the technological challenges, right? Like that you may not have seen 3 years ago when you start writing the grant that you're going to face that particular challenge, and suddenly you have to find money to sort of and capacity to be able to respond to that. So that, all in all causes the infrastructure to be less resilient, and them sort of scrambling or trying to find ways to be able to address some of those more imminent issues. And that is hard. That leads to a lot of burnout. That leads to just all sorts of maintenance issues for the infrastructures themselves. Increasingly, we're also seeing an issue with relying on a single funder or funding type or geography. I think ones that are coming to our attention over the past year in particular has been the shifts in US federal funding. So there are quite a few infrastructures in research that has been supported by US federal agencies, or indirect funding that are coming from US federal agencies. So for example, if the US agencies are giving money to institutions to pay for, let's say, membership costs for a certain data repository, right? Because of the reduction in federal funding, that causes downstream effects to membership fees revenue for the infrastructures. And the problem with that is that the cuts are often essentially nationwide, right? So it's not like one member is canceling their subscription to a particular infrastructure. It's all of their US-based members because of the budgetary constraints. And so then, it really has a significant impact on the revenue of some of these infrastructures at a very broad scale that, even till now, we're sort of trying to keep up and understand what that is. So generally, and the sort of system level challenge is that a lot of funders are, a lot of the funders in the research space has a national remit, including in the UK. And so oftentimes you do get, when you have national priority policy changes, that sort of thing, it does have significant impact on revenue of specific infrastructures that have, traditionally been funded by funders of that particular geography. So it is what I want to say here is a lot of these things, the three, so the innovation versus maintenance funding, the project-based funding, and the reliance on single funder or funding type or geography, these issues are not the fault of the individual infrastructures. It's not right to sort of put the blame on them. It's a systemic issue of how funding for infrastructure has been designed in this day and age. And so, this is the state of the challenge. And then the last one perhaps is something that, again, is hard, but we may be closer to a solution on to some extent. It's the understanding of cost, because when it comes to thinking about, okay, how do we build sustainable funding or revenue for infrastructures, it is also important to understand what it costs to run the infrastructure. And oftentimes what we see is infrastructures don't have a great understanding of what it costs to actually run the infrastructure. And again, it's not to place the blame entirely on the infrastructures themselves, but it sometimes, it is hard to understand if you can't understand your cost, you also can't understand where it may shift and how it will impact whether or not your business or your infrastructure is going to be sustainable financially. So it's something that we've been trying to see how we can sort of move the needle on and get more people to understand the cost of, for example, how much does it cost to actually host a particular data set, to enable open sharing of it, right? Like and it is becoming more apparently important, I think, as we do more research into buildings, financial sustainability and sustainable revenue models in the space. And then I'll quickly touch on the technological policy compliance and cultural adoption challenges. I think when it comes to technical challenges, I talked about, like, it's hard to, when you have, for example, the ecosystem moving from Python 2 to Python 3, right? Like, it's a bit of an old example, but like it takes human capacity and therefore money to do the migration. And so if you don't have that capacity or that financial resource, then you can't do it. And that leaves eventually a technical debt that you have to address at some point. The recent one that we've been paying a lot of attention to and heard a lot about is AI. So primarily, if for the example is data repositories getting hit by just an enormous amount of AI bot traffic, crawlers, etc., and that essentially is driving up their costs, because just to be able to handle that traffic, it's the bills are higher from their cloud services providers, etc. So it's something that it's very hard to anticipate upfront, but it's nevertheless something that they need to react to. So a lot of repositories now are putting in measures, for example, working with Cloudflare to think about how they can charge per crawl or etc. Like, they are forced to sort of put rate limiting measures sometimes to be able to continue their operations. And so that obviously then raises the question of, like, well, but we're supposed to be an open infrastructure, right? If we're rate limiting or limiting visits by certain domains or certain types of users, then does that contradict with our mission, etc.? And these are very challenging questions, and also require capacity to be able to start to address. So it's definitely very much ongoing. And then policy and compliance, procurement is one that we hear over and over again, particularly with sort of smaller and open source type infrastructures, where they are finding it much harder to get through institutional procurement cycles than their, let's say, commercial counterparts often. And that's also because procurement is often written in a way that is more designed towards those organizations. And so, if they can't get those institutional deals, then it hurts their bottom line. And that is a challenge that has been raised many times since we were founded, as well as the need to respond to new regulations as well, be it in, say, things like accessibility or data sovereignty, etc., to be able to, again, it's a little bit like the technical debt thing, where that you have to invest to comply with new regulations, and where's that resourcing coming from? And then last but not least, culture and adoption. If you are, let's say, building things like software registries or other things, like, first there needs to be a culture of discovering software and reusing software, and then to drive significant usage to the platforms themselves. And of course, it's a mutually beneficial relationship that way. But the infrastructure does not become an infrastructure without getting embedded in existing norms and workflows. So there again, it's sort of a bit of a chicken and egg, but we hear a lot of times that infrastructures are often thinking about, how do we get more people to use our infrastructures? How do we get people to understand what is the value that we can provide? And ultimately, that is also interrelated with all the other funding and other issues as well. So it's definitely a challenging set of issues being faced by open infrastructures. I don't want to just talk about a whole bunch of problems. That's not what we're here to do. I want to sort of leave you all with thinking about the fact that actually, it is a shared responsibility to sustain and maintain the infrastructures that are critical and we rely on as a research community, but it is also an opportunity. There are many different roles that it's not just about. Oftentimes when we get to this point, when we talk about infrastructure sustainability, then people are like, oh yeah, funders should fund this, funders should fund that. Yeah, sure, the funders are, responsible, and they can change things. But the power is not just with the funders and the policymakers. It is with the entire research community other types of users outside of the academia and also with the infrastructure providers. So for example, like specifically, I'm trying to be a little bit more concrete here about what we think each set of player may be able to do to really use their power to help sustain infrastructure and to play their role. Funders and policymakers, for example, a lot of times they're setting things like data sharing policies and data sharing mandates, and they would say, okay, you should deposit your data in a certain repository, but their investments may not align with, supporting the infrastructure that is needed for their mandates to be working and implemented. And so aligning, financial and other investments with the mandates that they're setting and funding what they require would be, something that they should look at and they should do. For the research community, I think, really helping the infrastructures that you're dependent on become more visible, become more value and advocated for. So when they are looking for user feedback, when they're, trying to articulate to a certain funder or other customers why their work is valuable, your voice counts, right? You can tell them, oh, I use this infrastructure, I use this repository, I use the standard because XYZ, and I particularly like it because it has great user feedback pathways, it has great features this way, these things are important to us, and that can really help the infrastructure understand where their value proposition is and help articulate that to the people that, will fund them, will support them as well. For people, I don't know if there's any in the room, but for folks who are coming from the industry and commercial user space, oftentimes they are dependent on this shared infrastructure, and sometimes they have not thought about whether or not they can contribute to it. And this is where I would say, yes, definitely think about whether or not you can contribute to sustaining it. And there are models out there that can facilitate financial and other types of contributions that are not just, a charitable donation. There are other ways and other models that can enable that. And so if you know people who are coming from that space, or if you are using infrastructures and coming from a commercial industry background, then it's worth thinking about how you can help support the things that you depend on, because ultimately, if they're not sustainable, it will also hurt your own operation and bottom line. And finally, last but not least, for the infrastructure providers, I think one of the things that we've seen over again that's becoming more and more important is really to invest in building your own governance, financial resilience, and capability to diversify your financial support and strengthen your governance. So I'll talk a little bit more about that later. So yeah, from working with a number of infrastructures worldwide to this point, we've learned a lot. And I think some of the things that we've seen with open infrastructure organizations is that the problem is not just about the funding. A lot of it is about the funding, but it is really about the capability. It is about the governance, right? So who is making and owning decisions within the infrastructure, how community and their stakes are structured. It is, of course, about financial sustainability. Can you diversify revenue beyond the single funder geography or funder type? Can you do multi-year planning? Can you do cost modeling? Can you build sustainable pricing strategies, etc.? And it is about business development. So how do you articulate values to funders and users and develop funder and partnership relationships that are robust and long-term? And these are particularly things that we've not seen. Well, funders really are quite rarely investing in these sort of organizational development aspects, but increasingly we are also seeing funders some funders starting to see the value of this, and this is where IOI as an organization, we can help. So we do work with infrastructure and funders on governance design, on financial sustainability planning, and on business development. So if this is something that if you're running an infrastructure and you would like to, if these are challenge areas that that resonate with you, I encourage you to come and email me and ask me in the question section. I'm definitely happy to dive into this a little bit more. But yeah, we're here to help. So I hope that I hope that I haven't left you with too depressed the vision, but I also want to again go back to my point that I think sustaining infrastructures is a shared opportunity. It is a way for all of us to contribute to building the research and science ecosystem that we want. I said I was going to go back to roads. And so here's a roads example that hopefully makes this more concrete, right? Like in this is a photo from a Dutch road. So I live in the Netherlands. Like we have roads like this, and okay, you're like, what is so special about this road? There are very deliberate design decisions that are made here, right? Like if you see that speed bump on the left there and the bike lane, right? This is there because these things are there because they are because we if I'm the person in the town, like we value things like not having cars drive really fast in a residential area to prioritize the safety of children and elderly that are living in the neighborhood. We have dedicated bike lanes because we want, less people to use cars and more people to use public transports and bike. And so, this in contrast with some of the city planning that happens, for example, in the US, where the planning is a lot more car-centric and is really driven towards, is really designed towards facilitating, cars to reach the point, to go from point A to B as fast as possible. Again, I'm not saying this to say that one way to do it is right or the other way to do it is wrong, right? It is about what we value as a society and what our vision is for the community and the town that we want to create. If we think that, it's important that people bike more for the sake of their health, then we would put in more dedicated bike lanes, right? And so I see infrastructure sustainability planning very similar actually to city planning. It's sort of like as the research community, different stakeholders in the research community, how do we come together to make these design decisions in our infrastructure such that it builds towards the research and science community and the vision for it that we want. And in that process, who has a voice, who has the loudest voice, and who are we not hearing from? Because if we only ever hear from the car drivers in planning this city, right, well, then we would obviously design a city where there are no speed bumps and there are no bike lanes, just 8-lane highways everywhere. And so, it is very much about making sure that as much as possible, we think the people that we think are important, that their voices are heard in these design and planning conversations and in the continuous maintenance and development conversations for the infrastructures themselves, so that we can enable the type of science and the type of science and the type of scientific workforce that we want globally. So that is as optimistic as I can be, I guess. But yeah, it is hopefully also the message that I hope to convey is also one that you do as an individual in this ecosystem have the power to be able to shape this planning and design to help create the world that you want to see. Leave you with this question. If you think about the infrastructures that you are depending on, what would it take for them to still be here in 10 years' time? Think about it. Happy to discuss further. You have my email address there, and please feel free to subscribe to our newsletter. Thank you.
It's always a challenge to follow up after Amy because she's doing amazing presentations. But I'll try to do my best. So I've already put the link to the Everest project on the Etherpad, as well as the link to the slides on the Zenodo. This is a presentation that I've been making recently as an overview of the project. But before I get to that, a quick self-introduction. My name is Konstantinopoulos. I'm a director of Bioinformatics Lab here at Institute of Applied Biosciences in Thessaloniki, in Greece. I have several hats in Elixir and other infrastructures. But in the context of discussion today, my main role is as a member of the ERAS project, which is an EOSC-funded one in the Commission. And as the name implies here, that the subtitle is aiming to implement or define a regional institute for research software excellence. The overall goal being to focus on research software quality, good practices, etc. So the main element, so everything will be software related, but I think I will be touching on a lot of the topics that Annie highlighted from the open infrastructures. And one of them is that essentially the reproducibility is fine in software is definitely a challenge, but most of the cases we realize that when we talk about software, the quality and sustainability of it is actually a huge factor. And so the question is, how can we help people do that? So one of the key structures that we have, mind maps that we have in Everest is basically this kind of tiers. We want to ensure that research software is a first-class citizen, which is far from the case right now. If anything else, we manage to leapfrog from data to AI models and forget the software that exists in between somehow. But in practice, what we are arguing is that software, research software specifically, is basically three different tiers. The first one is the analysis code, which is essentially any type of software that one develops, and essentially they use it for their own needs. From PhD students, master students, minor scripts, or anything else that ultimately the user of the software is the person who actually put in place. This is the more abundant in terms of software that's out there, but also the overall reach that it has, it's much more limited. Then some of this research software actually gets slightly more popular or more being used, and it moves to prototype tools, essentially software that is being developed by a group and used by others. Not widespread, but fine enough. The libraries, for example, are the most common type of this tier. Less abundant for sure. Reach is significantly increased compared to analysis code, but at the same time, the expectations of the software itself is much higher. Documentation, stability, efficiency, security aspects, all those are expectations in prototype tools. And finally, you have the research software infrastructure, essentially the least abundant in terms of availability, but also the more impactful and the wider reach. This is essentially research software that is the basis for others to do their software, their research on. An easy example given that is Jupyter and similar elements like Galaxy, which effectively are pieces of research software that act as the foundation for other research. So, of course, all of that is important, that it is different. How can we make sure that this is captured? So this is where ERS comes along. Ultimately, this is the one slide overview. What EVERS aims to do is to define kind of a framework of what we consider software and code excellence. And the goal is there's a lot of things out there. We don't want to recreate stuff, but rather collect, collate, and bridge what is already out there. Ultimately, it's an effort led by the communities, the scientific communities as represented by EOS science clusters, and ultimately is to be adopted by the communities. It already started 2 years almost to the day. It will last 1 more year. The project formally ends on February 2027, but we have a lot of ideas in place. So this is a slide that I try to keep updated as often as I can. And effectively what we are arguing here is that there are a lot of efforts around the software that cover science, the industry perspective, the communities, the software by itself, and then intermediate categories like software infrastructure, communities, science policy, etc. What we are trying to do as EVERS is to basically place it like in the smack middle of the whole thing, trying to make sure that we bridge as many of those things as possible and have as much of an overlap, because effectively what we want to do is the scientific software to be tied to the various communities that support software in general, and have the corresponding policies that says, okay, this needs to be better sustained, and we need to make an approach for that. Of course, as a project, we have a lot of groups participating here. You'll probably recognize a few here, and I'm extremely happy and honored to be able to be part of this effort. Of course, setting up the infrastructure itself, like the framework of good practices and quality assessment, is the end goal, but we want to demonstrate that this works. So we have a lot of pilots and drivers through the science classes. These are just a few examples that have been embedded quite early in the project, but we have moved way beyond that. So the next million slides here are basically on some of our key outputs. I'm not going to go into too much detail into all of them. So that's why I actually put the slides so you can look through them at your own pace of time. But basically, these are the 7 key outputs that we have produced. And I will go through them very briefly. And I'm acknowledging, of course, the people who were putting those slides in place a few months ago. So the RSQ is our flagship output, if you like. It's the Research Software Quality Toolkit, and it's a knowledge base where we try to capture information about good practices, recipes, tasks. If you're familiar with the Research Data Management Kit, the RDM kit, this is basically the same setup, but focusing exclusively on research software. It is quite extensively used, given that it is basically less than a year round, a bit over a year round, actually, now that I think of it. But what is more important to me is that there are a lot of people that are actively involved throughout, and that's the main rationale. The idea is that we have this as an open resource, so people who have something to offer or want to use it as a resource per se, they can actually get more actively involved, from actually adding content about efforts, ideas about good practice versus software that are relevant for their community or for their own, for the matter, or success stories, or simply going through what we have there and saying, well, yes, that doesn't make sense, this is wrong, this needs to be fixed, and I can offer some fix. So that's the quick and dirty version. What I did wrong? No, I went back and forth for a while. And these are some of the examples that I would like to emphasize here, because it offers both a knowledge base of these resources, but also as a means to connect to the other elements. So the good practices is essentially knowing what needs to be done or having information at your side. The next question is, how can I actually assess my software? And this is where the software quality indicators come along. Of course, as I said before, IVERS is not the first group or effort that I've actually tried to resolve that. There are a lot of efforts around this software quality out there, from standards like the ISO and IIC ones, from best practices like CHAOS and RFMD, and of course, tools like the OpenSSF and the citation file format convert and other really quality checks for software. So what we are trying to do is basically define what we would like as a group, as a dimension, if you like. What would be the corresponding indicators that can fit into that based on this immense wealth of indicators out there, and identify what would be the corresponding tool that fits into that. We already have a catalog of 34 indicators that we've organized across these groups, these dimensions, and effectively none of them are defined by us. We just reuse them. And although we have more than 840 indicators in the list, or on the back burner, if you like, these are the ones that we have put the whole stack in place. So essentially, we have the quality, the tool, and the dimension in place so people can use right away. Of course, this maps, as I said, to the communities, because some communities actually consider that this is quite important, need to be used. Some others are saying that this might not be that relevant. And it's the same if you go to the tiers themselves that I mentioned before. If you look at analysis codes, well, it is good to have or crucial for everyone. But if you have documentation for analysis code, it's good to have. But if you're talking about infrastructure, yes, documentation, you absolutely need to have that. This, as you can see, scaling of what is crucial and what is good to have is kind of going across the tiers. The higher the tier, the higher the expectations, and this is reflected also in the indicator. And of course, having the indicators as planned means that we can connect all the different things together, and I'll go to them in a second. Essentially, the RS toolkit is the knowledge, the qualities connect to the best practices, and then we can use pipelines like the recipe, which I say here, which takes the indicators, assess what is actually the tool that can provide this information, and bring the results to the end. This is an example. I can put a configuration file in my repository, a Git one-based or a GitHub in this instance. We run the recipe as a workflow. It assesses all this information or these indicators and produces a JSON file that is basically within the repository, and people can use it whenever. As I said, indicators are whoever the producer of the software defines. It's not something that needs to be defined by others. And usually the people who put the code together know exactly what other indicators they would like to have. But as a community, we can also make recommendations that I would ideally like to have those things informed as well. And if I have the information, it might be useful to actually show them. And this is where dashboards come along. Essentially, this is a demo. You have as an interface for your own repositories, institutional or group or community or whatever. You connect them to your dashboard, and then people can actually review what the situation is. And this is essentially the one that we have put as a demo for our instance. And you can see information about which dimensions are being used, which indicators are scored. You can add users, etc. It's an overall interface, dynamic one that analyzes information from the users. And last, I mentioned so far knowledge indicators and the process of extracting them, but we notice also the element of how we can map indicator to a tool. And this is where TakeRadar comes along. Again, knowing the tools, it is basically collecting what is out there. And we can find across these 12 dimensions, we improve from sustainability to maintainability to reliability. All of them have been curated and annotated by the community, saying that this can be useful in this context. And as you can see from the examples here, you can have multiple dimensions per tool. Again, the goal is to have this dynamic list. You can add your own tools, you can recommend tools to be informed, and then you can review and make the information can be expanded. These tool cards are used to map to quality indicators. And as you can see, this is an example of Docker, where having it as a tool improves some quality indicators, like having something within the registry, is published as a downloadable package, and it has depends managed solution. And it can offer measures of quality indicators like no critical vulnerabilities and has static analysis from vulnerabilities. All those are defined by people who are far from expert than I on this field. And as I mentioned before, all of those things are community driven, which means that anyone who has a remote interest in saying, I would like to do something about this, we have the contribution guidelines. It's open for everyone, and everything is basically GitHub-based. And last but not least, we also want to make sure that people receive the training to do that. Again, a lot of training efforts out there. So what we did is basically create an instance of TESS, a registry of training that Elixir has developed a few years ago, which we are calling an EVERS training, and it's hosted by CERN. And the idea is to collect this kind of training resources or activities if they happen, so that are easily accessible and fine for the rest of the team. Last two slides, I promise. I don't want to take more than that. This is a project, but we don't want to leave it as a project. So we already started from day zero to expand and engage with others. We have a very good collaboration with the Research Software Alliance, which is a global effort around software, and communities that are beyond Europe. Science for Africa Foundation, the RCM in Africa, and Telify, led by Anelda van der Voort, are the very easiest example I can give in this effort. And regardless of the challenges that we have currently overseas, in the initial phase of the project, we actually had some very good collaborations with the people on there. I'm hoping that in the coming years, we can resume this kind of connections. And finally, this is still EOSC, so we have established an opportunity area within EOSC to focus on software. which will conclude its first iteration this year. I think our mandate basically ends of December 2026. But we already know that we will continue roughly in the exact same shape and form from January 2027 onwards in the overall new structure of EOSC. And the goal here is to identify again and bring together communities around the different themes of digital software, from tools, policy, fair and quality, and impact altogether. My last slide, it takes a village, so nothing that I present here is basically mine. I'm just describing works of others, and I really want to say thank you to everyone who put this in place. Some links, but all of them are only slides. And I think with that, I can stop sharing my screen and thank you for your attention.
Thank you, Sarah, and thanks for inviting me here. I hope it's an interesting presentation for all of you. Maybe just a little disclaimer at the start. This is a talk from an open infrastructure on life sciences. So if you're not in the life sciences, everything that I say here may not be fully relevant to you, but nevertheless, I think this is still something that can be translated to other fields as well. So I hope you find it useful. I think it's going to be a little bit less detailed than Forty's presentation, but hopefully useful. Sorry, Sarah, can I check with you that you can see my presentation?
We can see and hear you perfectly. Thank you.
Perfect. Great. So yeah, I'll introduce myself. Shenia, I'm the Deputy Note Coordinator and also Community Manager for Elixir UK. You'll see that it says Earlham Institute just because we need to be based somewhere, but I'm fully Elixir UK, so a bit of a strange setup, but I think it will become clear as I continue telling you how this open research infrastructure works. So I'll start talking about Elixir, so from the European picture down to the UK. So I'll zoom in later on during the talk. And I want to also say that there's one idea that runs through the whole of the talk. So Elixir runs in very shared ideas into working infrastructure for life science research. And when we do it well, you never even notice it's there. So that's why I'm saying, and how we make it invisible on my first slide. So I want to start with the challenge that Elixir was trying to solve when it was formed. Life sciences is a very vast area, it's a very vast domain, and it covers a lot of breadth from genomics, proteomics, health, agriculture, data-intensive biology, anything you can think of life sciences data related. So the point is that it's too big of an issue for only one group, one team to work on this on their own, and that's why shared infrastructure exists. So there's also an issue of the scale of the problem. It's a matter of exponentially growing data. This is actually already very outdated. It's data from before 2020 and is only Emboli BI, but you can see the steep exponential growth of life science data. So it's not only the diversity, but also the problem of scale. This is just a quick representation as well for you to see all the diverse data types that exist in life sciences, if this is not an area that you're familiar with. So hundreds of database types and also hundreds of different standards and hundreds of different organizations trying to work on something that someone else may have built already elsewhere. So again, the reason why we need to share standards, connect resources and work together in that research infrastructure space. So I want you to picture something to start understanding how Elixir works. Everyone says distributed research infrastructure, and unless you've been part of one, it's quite difficult to grasp. So I want you to picture a few dots scattered, and these dots signify an institute, a university, a community working in isolation. It could be just a group running a database, and they are all scattered across Europe or even globally. For years, they grow in isolation, they work separately, they're brilliant, but at the same time, they are fragile because they're invisible to each other. The connections may happen ad hoc. They may happen because they see each other at conference, they see a talk and they decide to work. But it's not a systematic way of doing so, and it's one that is difficult to replicate. Its successes are very difficult to replicate. So what Elixir does is making those connections. This is the whole idea of Elixir. Elixir does not merge these dots. It doesn't take them over. It connects what already exists and amplifies it. So the services, the knowledge, everything that all these groups bring, they stay owned by the members, not by Elixir. And the elegance of something like this is that when it works, the researcher just opens a browser, gets their answer, and they never think, oh, Elixir was involved in this in any way. It doesn't even matter whether they own it or they run it fully, but the Elixir has had something to do with it. So seamless service is the goal. Like a road you drive on, not a building site, you have to navigate around and knock on every door to get an answer. And for those of you here that work in software, you'll probably recognize the irony that success makes the work very invisible. So this is particularly important with sensitive data. This is, I think, is a perfect example of a way of justifying why infrastructure like this matters. And you often can move the data across the border when we're talking about sensitive data. But you can build a system on top of it where the metadata travels and access happens safely in place. So federated, governed, and trusted by the people who use it and run it. But all of this requires not just the infrastructure, but the people behind it that are doing the lobbying, are making sure that this is trusted by government, healthcare systems. There's a lot more than simply the infrastructure. And this is again why Elixir is there, and Elixir is there to be distributed. So in practice, what we want is that a researcher, for example, in Norway, can work with harmonized UK genomic data without having to renegotiate agreements from scratch. So that's the kind of work, the kind of problem that Elixir is there to solve. And just to reiterate, we don't own that infrastructure, we don't own the science. Those belong to the members and the communities who build them. So what Elixir adds is that connective tissue. If you picture this into a more structured and organized scheme or diagram, what you see is that you have a few dots on the outer circle. Those are institutes, those are universities, organizations nationally. They form these orange blobs that you see in the middle of the circle. Those would be the nodes. So we convene those national organizations, those national teams, and then together we work inside of Elixir at a European level to create services and resources. So my favorite line, and it's one that many repeat, and I quite like to say it as well, is that Elixir reuses by default and invents only on demand. We connect what already exists, as I said before, we share the standards, avoid everyone resolving the same problem. Like I said before, you have two dots, they're invisible to each other, so it's very likely that people tend to reinvent the wheel once again. And we build those things to last. The mindset is that the difference between a tool that disappears and works in isolation is that there's an infrastructure behind that continues after the project ends, the funding ends, and maybe there's another more sustainable way of carrying that work. I also like to use this metaphor for our research infrastructure that most people, when we talk about open infrastructure, and I think mostly the researchers, what really lands is to say that we are building this for the people that need a bus ticket, not a Ferrari. So we don't need bespoke, expensive resources or subscriptions that only a lab with immense funding can actually pay for it. We need the bus passes. So the shared infrastructure that gets far more people access to the tools, compute, knowledge as well. So Elixir builds a road, and that's for anyone, including the Ferraris, to drive on it. Everyone who's felt priced out because they couldn't get into the big infrastructure science. So we make sure that that road is there for people to drive the buses that can allow many of the users to get access to the services. And those services, more concretely, are many of them in Elixir. These here, probably you recognize quite a lot of them if you are in the life sciences. These are the ones just for the Elixir UK. If you go into Elixir Europe, there's an even larger and very long list of resources that you will find there that are endorsed. Again, not owned, but endorsed by Elixir. That's even larger if you go and into all the notes. This is just the Elixir UK. So you can see the breadth and the level of extent to which Elixir is trying to endorse the services that are seen as those that are valuable, they are trusted, and it's a badge of recognition for the funders to say these are resources that we have to continue funding and supporting. So here's the scale that makes that metaphor that I was talking about real, the bus ticket. So together, these resources, they hold over 2.7 billion entries. And I have to say that data is already very old. I think it's more than 5 years old. The figure gets even bigger. And yet, when this was captured, the data more than tripled, while staff grew by only a sixth. So there's an enormous reach. There's a team that runs very lean and shared across the community. That's great. But that's exactly what a bus ticket buys you. And we need to continue building the infrastructure and making sure the people that are doing that work, the people that need funding, continue maintaining those buses and driving them. So every time that we see technology appearing, every time that we see a change, and we are experiencing a very different change that I'm sure you all have seen, so this is probably just preaching to the choir, but every time that we see an AI model answering a question about, for example, a protein, a gene, or a pathway, anything that we can think of, it's drawing on the decades of expert curation of all these databases maintained by Elixir. So if that curation stops, the ground truth runs dry, and this is not really anti-AI, it's a responsibility argument. AI scrapers are hammering on all of these databases that Elixir is endorsing and that a lot of people rely on, including AI, running up the costs and already pushing those teams out very stretched thin to the limit. So meanwhile, funding flows to shiny new AI projects rather than to sustaining those resources. And the curators often work on very precarious or rolling contracts that are not permanent roles at universities. So the catch is simple. The message is very simple. I'm sure you all know this as well. AI is useless if there's no source, there's no curator, there's no fair data behind it. So what Elixir's answer is that coordinated advocacy, and not just in Europe. The Elixir endorsement of a resource carries a quality signal that helps make the case to funders to say, these are strategic assets. These are not optional extras. You have to go for these. So globally, Elixir is also working with all the big groups like the Global Biodata Coalition. And the reality is that the weight of 24 countries and hundreds of organizations behind it is hard for a funder to ignore than if it's just the individual groups asking for it, demanding for a change in the funding landscape. And that's the difference between a tool that dies with just a grant in a team that is very annoyed, perhaps hundreds of users behind it, and one that becomes part of an infrastructure. Here is just a few examples of some policy briefs and documents that have come up, either through Elixir or by the influence of Elixir or just adjacent to it. I can share the slides as well so you can access to this. There's links on all of these pictures too. Also, another example of how we make the case is building an AI strategy. Currently, there's an AI ecosystem focus group, and I think I'm saying this name correctly because it's changed over the last months. It's more focus in the AI factories in Europe, but it's also another example of how Elixir is connecting all those different voices that they would have probably come out as very different policy briefs or position papers as opposed to a united voice that is merging the views of 24 countries. In terms of software, and quite important for people here as well, this is also going to touch on EVAs. So we are doing, for example, OECD workshops for research software sustainability. Again, the influencing power. We're involved in RSQ Kit, and maybe I'm not pronouncing this well either. And for EVAs, also writing policy briefs as part of some of the Elixir Europe projects like STEER, so you can see at the bottom. And the lines truly get very blurry because the reality is that people belong and work in so many different areas that Elixir reach becomes so vast and so varied. Votis himself, for example, he's been in Elixir far longer than me, and he's presenting here the work of EVAs instead of Elixir, but he could do Elixir as well. So just to sum it up, we have all of these communities, all of this expertise inside of Elixir Europe. These communities work into the projects that are either internal or they are European projects or even larger at an international level. And they work together to build those products that the end user is going to see. And this is all backed by the nodes, by the countries that make an investment on a yearly basis to be part of this open infrastructure. That's how it continues growing, not just with the projects, not just with that funding, but also the investment from every single member of it. And I want us to now go a bit deep down into how this works at a national level. I hope this is also interesting, not just for the ones that are in the UK, but also for the ones outside of it, just to see how an open research infrastructure would function when you really look into how it happens nationally. So to say it plainly, at least for us, Elixir is very broad by design. It includes many things, but Elixir UK is focused by necessity. We cannot cover all the vast expertise that Elixir Europe has. So what we do is funnel a lot of this. So if a member is interested in a domain area where we currently don't have the expertise or the time to work on it nationally, we simply push them to European level and we get the knowledge back into our community nationally. So again, the UK can lead on all of them. We concentrate where we are strongest. I'll show you in a minute where we are doing a lot more work now. And then we plot those trends into Europe and bring Europe's opportunities home. So in a nutshell, we are 31 member organizations. We're one of the more distributed nodes. So not just distributed at European level, also distributed nationally. And there's only one coordinated voice. So we write, for example, consultation pieces for the government on where we think that the funding rounds should go next for the life sciences. So we have real influencing power because we have 31 and still growing organizations behind it. Our strengths right now, they are focused on the FAIR principles, so anything behind fair data. We're leading voices in this space. Data stewardship as well. I'll show you an example in a minute. Workflows, you probably have heard already about Workflow Hub, Galaxy, Rockrate probably. On training as well, we have TESS. TESS is maintained in the UK at University of Manchester, and this is a portal to hundreds of registered training materials and events. Human data as well, we have HDR UK within our members, and therefore there's loads of people in our node who work on TRE sensitive data. And then we build the communities of practice. This is one of our key strengths. We are helping people that are isolated in the UK, maybe just a team of one that needs to work with other people across the UK. And that's hard to put together if you don't have the administrative power to build a community. So these are our strengths. We highlighted in the left the ones where we have leadership. So you see in orange all the different places where we have a UK lead in there. But this is very shared ownership, very, very shared way of building a community. So you will see a UK lead alongside someone else from Spain, France, Greece. Is very distributed. At national level, like I said, we're focusing on 3 communities. So that's training, data management, and human. And actually very soon on core bioinformatics facilities as well. And just to make this a little bit more tangible, I want to give you 2 very good examples of what we've done nationally. One on the side of influencing power, and the other one on the side of ability to empower others to do things. So this one, the Elixir UK Fellowship, is actually one very personal to this room. Elixir UK and the Software Sustainability Institute go back a long way. And our Fair Data Stewardship Fellowship was built in partnership with the SSI and inspired by this very own fellowship model. So it trained around 20 fellows that were data stewards, or maybe perhaps without having that title, as fair ambassadors in their institutions, and then they produce reusable training and RDM bites, small videos, we call them RDM bites, and grew a community of practice around it. So very similar to what you're doing here. It became one of the most successful projects we've run, and the impact still landing even 2 years after the end of the project. We were unable to continue funding it for more rounds, but those 2 cohorts that we ran had a huge impact. Right now, Elixir Netherlands, for example, has already replicated our model. So this is not just our impact, but the impact of SSI on yet another fellowship being done in a different country. So this is just to show that it's not just the tangible bits that an infrastructure helps, but actually also the not so tangible bits that they help. Because the fellows, they were saying that they had so much more power locally because they were no longer a single voice on data management. They had a community and infrastructure behind them. So they gained that important goal of them, that it was to be heard, to be listened, and to not be invisible because they were working in isolation. On the more tangible side of things, the ability to influence power, We did something around there, not just talked about it, we actually convened an infrastructure, we conceived it. This is BioFair. If you're in the UK, you may have heard this, but maybe not if you know in the life sciences. This is a £34 million project funded from UK, right, to build a national biocommons that connects what already exists in the UK and even brings some of the pieces from outside, for example, now focused heavily on Galaxy and how that could be implemented in this commons for the rest of the UK research community. So as of today, this is already its own project, separate from us, different in governance, but we're still very involved in it in a lot of ways. I've put here a couple of examples. We've been given the method commons. Our head of node, Carol Gobble, is leading this project. So we're still building a lot of it inside of BioFair. This was a competitive call, and it's going to bring a lot of the Elixir resources into this new commons in the UK. On the other side is a Pathfinder. This is a more community-driven project that I will be leading, and it started a month ago. So you can see where Elixir is still being part of something that we formed nationally, even though it became its own thing altogether with a huge investment at national level. And just to finalize my talk, I want to say that it really takes a village to make such a huge change. And I think if you are in research software engineering, you've heard this many times. It also applies to us because we need so many people with so many different types of expertise that really takes a village to change this. So this is a picture from our All Hands in 2024. I think it's a lovely picture, and it shows this is just a fraction. And I think the community you're building here with the SSI and the community of people that we can even merge in between research infrastructures really makes a difference. So I hope you here doing your fellowship will continue growing even bigger things. Even through connections with others, we do so as well. We engage with other international research infrastructures. We're part of other projects like EVERS. So really is a matter of making those connections, even connections that we didn't think they should be there because you won't necessarily partner with someone in the life sciences. But we've seen this happen already. Some things that we've done in the life sciences, they've been now used in the physical sciences, for example. So to finalize my talk, just to say that I hope this was useful for you to see how an open infrastructure was done, but also to tell you that you may find it useful to come talk to us, whether it's UK or you reach the European one, because there's so many FAIR tools that may be useful for you. You may already know, you may not. So I really encourage you to have a look at all the services that are endorsed by Elixir. And also to say that you're more than welcome to join a community, whether it's nationally in the UK, we open it to all, not just UK, or at the European level. These are all open communities. I'm thinking, for example, anything that comes out of your fellowships, it would be fantastic to see how others can reuse it. So if you have something you want to share with another community, let us know. We would be very happy to give you a space.